This is basically an experiment that I had started running to compare performance between a standard shopping campaign and a corresponding performance max campaign. The shopping campaign had been running for quite a while and it wasn't doing all that well. So I decided that why not give a performance max version of that campaign a try. Okay, so this was for a specific product for that particular brand, and what you're seeing here is the results of that experiment. So as you can see, the experiment is actually still going on, and this is the inbuilt Google Ads experiment, by the way. So as you can see here, the performance comparison is for the date range 17th March to 24th of April, and the experiment will automatically end on the 2nd of May, as Google is saying here. Now it's saying that okay, still there's still some time left for that experiment to go on, so it's asking us to come back after 4 to 6 weeks, right, to get conclusive results. I'll just explain in a moment what we really mean by conclusive results. This is a very specific point and it's important to understand. So the whole purpose of this video, is to fully understand A/B testing and experimentation in the context of not just Google Ads, but for any platform. But I'm going to be using the example of Google Ads. So this is not a very big experiment. But I'm going to show you the bits and pieces of it so that you can run your own experiment, your own A/B test using Google Ads, and you can also use this concept to extend it to any platform really. So as I said, the date range was it started on the 17th of March when I actually started the Performance Max to run side by side along with shopping and the standard shopping campaign, and it has been going on now till the 24th. Today is the 25th when I'm recording this video. So without further ado, let's get into it. So what it's actually going to say is how much has been the overall lift in performance. Okay, so what that means is what are the different metrics. So as you can see here, there are only three metrics. So of course you can add a few more metrics here. For instance, you can add clicks, impressions, and all of these things, conversions, and all of these things are going to be here. You cannot select more than 4. All right, let's just leave out conversion clicks then. Okay, fine. So these metric tiles are going to appear here, as you can see here. So what this is actually saying, if before actually showing you the results, is that the Performance Max has had a lift of 21%. So if I look at the graph of this, so as you can see here, the conversions is up by 21% for Performance Max compared to the previously running standard shopping, and the revenue has gone up by 11%. The ROAS has dropped a little bit comparatively, and but yeah, the spend has also been 15% more in the case of Pmax. So this is what the overall results are. But again, the results are not conclusive yet, right? The experiment hasn't ended, all right, as it has said. So it's going to go on for the 2nd of May, but we are seeing the results up to this point. And what Google is giving you the option here is that it's saying that it's apply experiment, right? So it's saying that you can apply the results of this experiment or you can end the experiment as well, all right? But obviously, it's not advisable to apply the experiment this early because it's not yet reached its logical conclusion, right? So it's saying that in order to get the conclusive results, you should be waiting for a month and a half more. So if I just jump into the section now where it's talking about the campaigns. So so in the last part we had discussed about the initial part of the experimental setup and what we are really testing here. So we are obviously testing for standard shopping and Performance Max. There was a bit of an error here, so I had to reload the screen. This is the experiment results here. So we already saw from the tiles right here, the metrics tiles, and we can add conversions, for instance, as well. And you can see here there's actually a lift in conversions, there's a lift in revenue, and all of that. So if we actually make this comparison now, So you'll see that there's actually been zero conversions from the stand shopping in this date range for the period of the experimentation. And if I actually include clicks, for instance, instead of ROAS, and you'll see that the number of clicks is plus 277, so it has got more clicks than the stand shopping campaign. But from the data, what has actually happened, I'll just be explaining these things in a moment, but what we actually observed is that there were more clicks in the Performance Max campaign for this period than the standard shopping campaign, and this is a problem, all right? It says here that it's 50% traffic split, but this is not what happened in reality, okay? So this is called the sample mismatch ratio, okay, this particular situation, and this is not something that's desirable because then it's not comparable, right? So you should always have a 50% split. I mean, not always, but at least if it's a relatively simple setup, then that's what you should aim for. However, despite that being the intended case, that was not something that was achieved, and that's why these are not particularly comparable, and that's why what Google does is it sometimes uh, you know puts together comparable campaigns so as to get the desirable experimental setup, all right, so that the A/B test output is actually meaningful. So that's why you can see here there's something called comparable campaigns. So if I actually click on settings here, you can add comparable campaigns, all right. What it does is then it includes campaigns which are of similar sort of location settings, basically very similar, all right. It's not particularly very logical. You'll see all the time what kind of campaigns it chooses to club together with both of the control and the treatment group, all right. So obviously the control group is shopping, as you can see here, standard shopping, and the treatment group is Performance Max, all right. So when when we are actually putting these two in different groups, you also know that that they are supposed to have 50% traffic split, but sometimes in order to get the experimental setup correct in order to get the traffic split correct, sometimes Google will add few more campaigns in that particular group. So for instance, if we go ahead and click on settings and include these comparable campaigns, it will actually show include more campaigns together with the standard shopping, all right, within the control group, so as to reach uh, the target traffic that's required in order to match Performance Max, all right. It can also include few in this group also, all right. So essentially that's the idea, but it's not a great thing, right? So that's not what I'm seeing. That's why I've not included those results here. It's not 50% traffic split, but still at least we get the pure data which is unadulterated by any other campaigns, all right. So that's what I've done here. So the cost is 280 for the standard shopping during this period. For Performance Max is 392, and the difference in cost is 111. Now, what's the difference in revenue? So we are trying to understand performance in terms of revenue, conversion rate, or ROAS, right? So the ROAS is obviously plus 1.36 because it's zero for standard shopping, and similarly for in terms of revenue, it's plus 531. So it's a clear winner, right? The Performance Max for this date range of the 17th April, 17th of March to the 2nd of April. Obviously, it's going to continue like I was talking about in the last part. So the difference is 40% in cost, and now comes the very interesting part. What do we mean by statistical significance, and what do we mean by its confidence interval? So there's actually a lot of statistics involved in it, all right, so I'm not going to go into the depth of all the statistical analysis right now, perhaps in future videos, but you can always tell me if you want to understand more. But what it really means and the way to read it is to is this. So there's actually 95% confidence in the experiment's ability to claim that there's going to be a difference in cost between 22 plus 22% to plus 58%. All right, that's essentially what it means. The problem is that this is not being shown in terms of revenue and ROAS. All right, that's essentially the problem. So you have to include some other campaigns here. All right. So if I just go ahead, just include a few comparable campaigns, then you see that some comparable campaigns have been included, and then you see even then you actually not do not get any statistical significant data for revenue and ROAS. All right, so statistical significance has not been reached. All right, for this experiment. However, if I jump to another tool now, so this is a very popular tool, ABTestGuide, and I highly recommend you to give this tool a shot. So if I actually use this tool to understand some of the data, so this was actually the number of clicks for the stand shopping campaign at 943 was the number of clicks for the Pmax campaign during this period of experimentation. And what I've done here is, this is visitors A, this section, this is to be treated as control, this is to be treated as treatment. All right, this is to be considered as treatment group. So you just have to provide the number of clicks here in these two boxes, and then the corresponding number of conversions for the control and the treatment groups. And then when you hit apply changes, you immediately get a result. All right. So a lot of things here. So first of all, this is showing that this is actually a significant test result. And that's because this is all that it is considering. All right. So the number of visitors here, and you will see that the conversion rate was obviously far higher, and there's a 95% confidence that this result is a consequence of changes that you have made. Right? So the changes obviously is that we also tried Performance Max, but at the same time there is the possible SRM alert. Like I said, the sample ratio mismatch rather, that actually happens because the 50% split in traffic was not actually adhered to, right? So the number of visitors are different for the two versions, the control and the treatment. Now let's look at the expected distributions of variation A and B, and it's very interesting. All right, if we look at the two graphs and the tables, so there are some very interesting numbers here. Obviously, the conversion rate of control and conversion rate of treatment group, we already know this is 0 and 1.27. So the relative uplift in conversion rate is going to be a very important in your experiment. In this case, it's infinity, because obviously we are dividing it by the conversion rate A, which is the control, and because that's 0, we are getting infinity. All right. What is observed power? So another very important concept. The observed power is the ability to actually explain, or not explain, but rather to the ability to reject the null hypothesis when it is really false. Okay, so essentially, it's basically the power of an experiment to predict correctly. All right. So the higher this power, obviously, the higher it is. The higher is the accuracy of the experiment. So it's very close to 100%, as you can see here. So that's a good thing. When we talk about null hypothesis, there's also another thing called alternative hypothesis. So in this case, the null hypothesis would have been that there is no significant difference between sample mean and population mean, meaning that there's no significant difference between the control and treatment variations. But of course there is, and that's why we rejected the null hypothesis, and that's why the observed power is high. And p-value is again very, very important, and this gives you an idea of how statistically significant your experiment results are. So usually we go by something like a 95% confidence interval. As you can see here, that's already been selected by this tool, and that would typically correspond to something like a threshold value of 0.05. So anything that's under 0.05, a p-value of under 0.05 is usually going to mean that the experiment is statistically significant, and in this case we see that it's indeed the case. The z-score is again a very similar kind of concept to the p-value. It gives you an indication of of the level of statistical significance. It is calculated by this, as you can see here, is calculated by the difference of the means between the observed and an imaginary hypothetical mean, and then you obviously divide it by the difference of the standard errors. So that's one way to calculate it. There are actually various variations of the z-score formula, z-score formula, and the higher it is than your threshold value. So in this case, it's actually 1.96. Okay, so that's the critical z-score value corresponding to the confidence interval. All right. So we always take in such cases we assume normal distributions. So in case of normal distributions, for the 95% confidence interval, the critical score is 1.96, and since it's much more than that in this case, it is actually also a sign of statistical significance. So this AC is basically the standard error, and the standard is basically the root of the value minus predicted value square of it, and then you take the square root of it divided by n minus 2, where n is the number of observations. So there's actually a very detailed formula behind it, but without going into that, we can say that standard error is essentially a kind of standard deviation, and standard deviation gives you an idea of the spread, right? How much deviation is there from, for instance, the mean, right? So these are the individual standard errors, and this is basically the difference of the standard errors, all right? So this particular thing has actually been calculated here, as you can see, which is using the individual standard errors, and that value is 0.00365. And if you actually take the difference of the conversion rates, which is 1.27, and then you divide it by this value, approximately you will be getting this particular value, all right? Because that's what it is, right? It's the difference of the conversion rates here and dividing by the standard error, and the standard error difference rather, and that's what you get. So this is a very useful way to do your A/B testing. This is going to give you some indication of the significance. Although strictly speaking, as you can see, what Google just said, that there is no yet statistically significant data. All right, as you can see here, for conversion value for ROAS, it's only giving you for cost, and so it's, as you can see here, the interval that it's saying is between 22% to 58%, so it could be anything between that, and it's a very high interval, by the way. And I'll give you a very interesting tip here. So suppose this was for revenue, okay, and if you had some sort of a confidence interval, and at a 95% confidence level, if you had an interval of say 22% to 58%, say for revenue, so and obviously that's very big, right? I mean, you would want something like say 25 to 30%, or 45 to 50%, a much smaller range, right? Not such a high range, because if it's so high, then there's a lot of variation, right? I mean, there's a lot of unpredictability. You would want it to be more predictable, that okay, if I run Pmax as opposed to standard shopping, I would be certain within this level of variation only, all right, 5% level of variation only, that I'm going to get a certain percentage of lift in revenue. But if the variation is so high that it can be 20% high and it can be 50% high, then that's not good enough. In that case, what you need to do is you need to reduce your confidence level, all right, from 95%. You can reduce it to 90, you can reduce it to 80, and so on. Ideally, you would want it to be 95%, because that's typically what looks good on paper also, and businesses would also like that, because that just sounds good, right? It's so close to 100%. But the reality is that it's not always possible to get so close to 100%. In that case, and that is typically the case when you want to reduce the interval. When you're getting such high intervals, the first thing that you should be doing is to gather more data. All right. The more data you have, the lesser is going to be the variability, and the better is going to be the interval at even a high level of confidence. But if you want to reach statistical significance even with limited data, and sometimes you have to do that, then in that case you need to reduce the confidence level. Okay, and the best way to do that, I'd say, is to use this sort of calculators, because you can choose between different confidence levels. So this was the overall idea. I know it's a pretty loaded video. There's a lot of concepts involved, but I hope that this was really helpful. And if you need any kind of help, just let me know. When you need to run Google Ads experiments, or even experiments on other platforms, or any kind of experiments really using data from marketing, and I'm more than happy to guide you in the process. So yeah, do let me know. This was specifically for testing between standard shopping and Performance Max, the inbuilt experimental setup in Google. And it's always preferable, by the way, to use this sort of setup, and that's because in this side of setup, the platform is actually able to carry out the traffic split. All right, you won't be able to do that very systematically if you are not using the inbuilt experimental setup. So I definitely recommend you to use that. Hopefully this was a useful video, and I'll see you in the next one. If you like the video, please give it a like and do subscribe and share. Thank you.